Take a moment to check in with your neighbor, just make sure their work is going okay. I'd like to call on 3 people in just a moment. You about ready? Let's get started. Dan, could you tell us one way that you did and talk us through it? X plus 1. Okay. Are we good? Should we check? You could, but generally these quadratics, if you get it right, like if you get something pretty, it's going to be right, but it's not a bad idea to check, especially if you have a couple of seconds on the test or quiz. It's easy enough to plug in the numbers and make sure that it works. Dan, thank you. Ben, what's another way you use? Okay.
You x squared plus 6x, you say equals -5, leave some space. And then it would be 9 because b over 2 squared. And then there you get x plus 3 squared equals 4. And then you get x plus 3 is plus minus 4.
Plus or minus what?
Oh, 2.
Because of math.
Equals -3 plus minus 2. And then you get -5 right.
Are we good? Very nice. Thank you. Ethan, what's another way? Okay.
Squared minus 4 parentheses 1 parentheses 5. So we'll just get that up for 2. So we that's the continuing to plus or minus 6 60. And so that we're going to over 2. Simplify that and get I got -3 plus minus 4.
Plus or minus. We have to divide that by 2, right? So here was 16 over 2. Yeah. Bless you. Great. Any questions? Which one would you choose to use? Yeah, always check factoring first. With factors, that's the way to go. If you're not sure how to factor, do something about it. But like if you just freak out on a test and you forget how to factor, it's too late to do something about it at that point. So what should you do? Quadratic formula will always get you. It's just kind of a long cut, isn't it? Or the scenic route, as I like to call it. But it'll work. Yeah.
Will we be able to cheat?
Good question. I'm not sure yet. I think by and large you will be. Um, but like the quiz, I think it said solved by this, solved by that, solved by that. So we'll see. I don't know. You should be able to do all of them. You should be comfortable, like whatever curveballs I throw at you, you should be able to bring it on. Yes, sir.
Are we getting the quiz back today?
Yes, you are. Before I give back to you, I want you to quickly discuss the date with your partner, and after I'm going to give you a moment now to change seat.
So, November 32nd. November.
So pretty easy, isn't it? 36 minus 25. Could be 11, or is it maybe plus or minus 11? That wouldn't make any sense. But let's look at this from the eyes of an Algebra 2 student. Would you please discuss what's another way you could solve x squared minus 5 squared? How can you figure out what that is in Algebra 2 fashion? Algebra 2 style. What the heck am I talking about?
No. Is it square minus 5 square?
Do you recognize what I'm talking about? It's a difference of squares, isn't it? And anytime you see a difference of squares, that means you can factor it. So this can be factored into 6 minus 5. Does that make sense? So 6 plus 5? Right. Did that work out to be the same thing that you just got? Now, is it a nerdier way to do it? Yeah. Is it a better way? Probably not. Probably not. But maybe if you had something like, I don't know, 79 squared minus 78 squared, that it might be easier to do it that way. Because then it just becomes 79 plus 78 instead of what the heck is 79 squared? I don't think we're gonna get to that date though. I have a feeling it doesn't happen. Not on Earth, but who knows what's coming in the future. Yeah. Okay, so let us get to today's work. Oh, like I said, I do have your quizzes. Uh, mixed, mixed results. Um, I don't require quiz corrections, but since this material will be on the test, I recommend that if you got something wrong, fix it, come back stronger on Friday. There was one perfect. I'll let them reveal themselves if they like. There was one perfect score, and they may reveal themselves if they like. I'm not going to expose them. But here we go.
Well. Oh, Lord. My doctor won't. Yeah, that's. Thank you. Yeah, we were the reason why they. I got. Who? Oh. Shit. What was it? Oh, no. Wait. Oh, no.
Probably.
Wait, how did you remember this? This one?
Each page is worth how much?
No, each question probably worth like points, right?
Well, I'm trying to.
Well, because how much important I was to figure it out. What did you get?
I'm not laughing. Jeff, or did you get C, correct?
Yeah.
Oh, what was the end?
Wait,
Said it was -3.
negative, I got negative.
Oh, because you have to plug it back in.
Yeah.
Ah. You have to plug it. That's not like it.
Another 10 seconds before I ask you to put the quizzes away.
Well, I would start like.
Well, this is like a document.
Okay, please put your quizzes away if you haven't already.
I see.
Yeah.
Oh, I got
Yeah.
it. Well,
I got a lecture here.
I did that.
I was savage.
Okay, so some words, and I'll repeat this from time to time because it's an important message, and sometimes it's harder than others to get through and make sure that these messages make sense to you. I want your experience in this class to be meaningful. I want your time here to have a lasting impression on you. And what that looks like is feeling happy, feeling content, feeling proud, feeling ready for the next level. All these things. I want that for you. But remember, it's teamwork. I work and you work. So for those of you who are working really hard, I really appreciate your efforts. And I think everyone's working pretty hard. And I want also to remind you that I'm on your team. So if you're if you're working on the homework and you're not seeing the results on the tests, let's connect. Let's see what's going on and make sure that your efforts at home or just when you're doing your work, make sure that translates to success in the class. So that probably means meeting with me or going to math lab or putting in a little bit of extra something to say, hey, what's going on? I understand on the homework. Why isn't it happening on the quiz? Or I'm not getting the homework. How can I make that happen so that when it comes time for the quiz, when it comes time for the test, you fly? That's what I want for you. So please remember, we are a team. I work, you work, and there's no room for guilt or shame in this class. There's only room for feeling proud. That's what I want for each and every one of you. So with that, let's finish the unit, shall we? Let's do it. Interval notation. It's used when referring to an infinite, I'm pretty sure I spell it on. Infinite number of values, all next to each other, next to one another. I believe you're familiar with the graphs on a number line, yes? Now, gentlemen, I often ask the question, how many numbers are between -2 and 3, like in A? And some people say that there are 4 numbers in between -2 and 3. What do you think? It is true that there are 4 integers in between -2 and 3, but there are an infinite number of numbers in between -2 and 3. Does that make sense? Because in between each number is another number, and in between those numbers is another number, and it's just packed with numbers. So generally, we don't list those all. That would take a long time. So graphically, it could be represented like this. Algebraically, does this make sense? Is that this says the same thing? And this is read, x is between -2 and 3. Not -2 is less than x is less than 3. X is between -2 and 3. Interval notation. I'm going to do A and B, and I think from there you're going to understand, or many of you understand notation. I start with -2 and go to 3 for both of these. But there's a difference between A and B, isn't there? So an interval notation, what I do is I'm going to write it like this for A, and for B, I'm going to change those parentheses to brackets. Have you seen this, son? It seems like some of you may have seen it. Both of them indicate an infinite number of points, but the brackets indicate that we are including those endpoints as opposed to the parentheses. And do you all agree that this is confusing? It looks like something else, doesn't it?
The answers.
It could be like the answer is -2 and 3, or like something from a graph, like an ordered pair. When it doesn't look exactly like that, you go -2 and up 3 or something like that. So just make sure that you understand contextually what it's referring to. If it's talking about a set of numbers, it's going to be interval notation. If it's talking about a point on a graph, that would be an ordered pair. So C, could you already do that in interval notation? I bet you can. Check with your neighbor for a C. Okay, so of course with this one we're going to begin with parentheses, and end with brackets. Yes. So each one of these three things, see the graphically, algebraically, and interval notation, they say the exact same thing. Would it be okay to do this, do you think?
Yeah. Oh, no.
Although I appreciate the effort and it technically, like all the pieces kind of are right. It's misleading, isn't it? And we always go from left to right when we're talking about interval notation. So with that in mind, I'm going to give you a chance to do D through I.
I'll be supposed to know if we-
Yeah, well, I want you to talk about it and think about it. Maybe we'll do D and E first. I think that your question is probably about E, isn't it? Okay, I'll give you a chance to do D and E, then we'll talk about those. So for D, of course, you started with brackets, -2, 3. You all have that? Okay, but E, I know that you started with the correct thing. You started with brackets, didn't you? Let me make that a clearer bracket. And then what after that? Yeah. And what are we going to do at infinity? Parentheses or brackets? Well, the question, does it reach a particular point? It doesn't reach a point. That's why we can only use the parentheses. There.
That's always gonna be. a parenthesis.
Always parentheses. Unless you find a way to reach it. So F, same thing, isn't it? Except parentheses. G, I'll give you a minute to discuss with your neighbor. How would you do that? Hey, would it make sense to start with a bracket and 1? Would that make sense? No, that's the end. We know that we're going to end with the 1 and the bracket. Aren't we? Does that make?
Know which it's greater than or less than depending on where. For F,
Oh, for F?
like you know, -2 is gonna be on the left. Like, how do you know if it's greater than equal to?
Oh, good question. Let's finish G and H and then get to the greater than or equal to. So I hope that we're good with that G has to end with the 1 and then a bracket. But what do we start with? Negative infinity. Does that make sense? There are two different infinities on the number line. There's negative infinity and positive infinity.
Yes.
It's the end of the negative. Well, it's not all of the negative numbers. Like negative, these are not involved with negative infinity. It's just negative infinity says we go that way. How far? Forever. Forever. Of course, in this interval between negative infinity and 1 is all of the negative numbers. And a little bit of the positive numbers, just infinitely many of them. Okay, so H is going to look different. It's a little different. Instead of brackets, parentheses, from negative infinity to 1. And I, negative infinity, positive infinity, and both of them have parentheses. Yeah. So Ben, your question was about the greater than or equal to?
Just kind of confused if it's greater than or less than, like which way you put it like where you put the number, like for negative, for F.
Mhm.
Even though -2 is to the right of the X, you put it on the left with the integral notation.
Oh, it's always leftmost.
Like, how do you know, say you're just given the right side, how do you know which is which?
Rightmost. You're just given which side?
Given the right side of like -2 and infinity.
Like E?
Yeah, how are you supposed to draw the inequality for that?
Draw the inequality. Well, like E is represented. Well, I'm looking here right now. It's represented that way graphically. Algebraically, it's X is greater than or equal to -2, isn't it?
It's because, okay.
Right? These are the unknowns. These are the X's that we're referring to. They're all greater than or equal to that -2. Did you clear up? Okay. Any other questions? Thank you for asking. Okay, let's talk about properties of inequalities. Let's say that A is less than B. And here's my number line. What do I know about A and B? Yeah, A has to be on the left, doesn't it? So I'm going to put an A right here and put a B right here. I'm actually going to mark. Are we good at that? A is less than B. It is just the visual representation of A is less than B. Now, if I say, you just take that A and B and hold A in your left hand and B in your right hand. If I'm going to add something to both sides, what's going to happen to A and B? We're going to add, they're both going to move. And it's still going to be a less than sign. If we go back to A is less than B and subtract from both sides, we're going to go this way. I need to add something here. It's not necessarily true, but I'm going to put a 0 in there, which means that A is now a negative number and B is a positive number, of course. I'm just putting it here, just I'll go over 2 examples. One where the 0 is in between, one where it's not. Okay, so we have our A in our left hand, our B in our right hand. If I multiply them by a positive number, do you see what's going to happen? If I multiply them by a positive number, it's going to do this, isn't it? Where we don't change anything. But if I multiply them by a negative number, what's about to happen? They switch, don't they? Does this sound familiar? When you multiply an inequality by a negative, you just have to be careful to reverse that inequality. And that's why it's just they kind of change roles. But thank you for asking. We don't exactly know where that 0 is. So let's say that 0, maybe these are both, maybe these are both positive numbers. And let's say the 0 is over here. Do you see what would happen to the A and B if you multiplied it by a negative number? They still move to the other side, but when they still reverse? So no matter what, no matter where that 0 is, they'll still reverse. So just remember, the only thing I'm going to write here really is when multiplying or dividing by a negative number, reverse the inequality. Do you think that would be a good thing to put on a test? No. Just keep it addition. Okay. I'll consider that then. No promises though. Okay. So here we have 3 minus 2x is less than or equal to 11. So first thing I do is I say the 3 minus 2 is 1. Is that correct? Well, it's true that 3 minus 2 is 1, but that's not the first thing we do. The first thing we have to do is subtract 3. So I have negative 2x. And is it okay to subtract 3 from both sides of an inequality? Yeah. Next step, divide by. And when that negative goes off in your brain, that's when the alarms sound. X is greater than or equal to -4. And for those of you who are still doing the -3, please, a reminder that you can stop that as soon as possible. I encourage you to stop that as soon as possible. Right, to write the -3, just that's fine to be in your head. I don't need to see that work anymore. That's really good pre-algebra and algebra 1 stuff. I don't need to see that anymore. Okay, so it says to write your answer in interval notation and graph the solution on a number line. I'm going to graph it first. The fact that it says x is greater than or equal to -4 means the only number I really care about on this number line is -4. I'm going to put that right here. I'm going to put what kind of a circle there? Closed circle, and then I'm going to, I could shade to the right, but I'm going to do this, like ease up on my pencil and just say it's going to the left. I think I said to the right. It is to the right, excuse me. Good question. Should this be closed or should it be open? How do you know it should be closed? Because it includes it. It's equal to it. So yes, it definitely matters. Please write this in interval notation. Check with your neighbor. So we begin with, well, I want to hear from someone. From James. How do you write this in interval notation, please? Are we good? What do you think about interval notation so far? Oh, it's perfect. Yeah. It's James, of course.
He was asking a question.
Ah, there you go. Okay, I got B, C, and D to try. I will be calling on 3 people. You're doing B, C, and D. Thank you for asking. Yeah. Make sure to check in with your neighbor. For B, I'd like Luke to come up. C, Mia Rose, and D, Joseph, whenever you're done. There's no rush, but so Joseph, you are D, please.
Yeah, and then we're past that. Good lord.
Looking silly.
Yeah, I think we're past that.
Did he get out the beans and start counting? Is that what he did? Hmm. Oh, yes, please. See. Oh, other things back here? Wait, no? Oh. Oh, pretty.
But you're so close.
Really?
Unless I'm wrong. I don't think I'm wrong. But the X is less. The intervals, right? No, the interval. It's the interval.
Oh.
It's
wow.
negative infinity, then -3.
Jack, I like that.
Think.
I found, you can start the whole.
You agree?
I concur.
Okay, yeah, I'm just gonna go with Luke is wrong.
You concur on that?
Yep.
Are you sure?
Oh, shoot,
Yeah.
I can concur in like, oh, wait. What is that, 18?
It is.
Oh,
Yeah.
oh, wow, oh,
Well, 'cause the thing is now that I'm on.
we really fast forwarded.
Oh,
Yeah.
that looks better.
Yeah. Hey, Luke, you were really close.
But it's the thought that counts.
Yeah.
And partners.
Yeah, like. Okay. It's a little bit weird. Don't you agree? It's a little weird. When the X's are gone, what are you supposed to do? So here, should I like subtract 3 from both sides or something? Or subtract, what do I do?
True statement.
It's a true statement. We know that 8 is definitely greater than 3, which means, yeah, no matter what X was, we're left with a true statement. So all real numbers. Or of course, you can say X. Have I shared with you this symbol? I forget. X is an element of all real numbers. So to graph that, is it asking us to graph and use interval notation? It isn't asking, but let's do it anyway. So to graph it, of course, you just make sure that your number line, including the arrows, is dark. Control coloring this in here. Right, you just make sure that it's all. And then negative infinity to infinity. And this one, there's no way to help this, right? There's just no value of x will make this true. So no solution. So on a number line, how would you do that?
No, nothing.
Maybe you could write empty to make sure there's no
Just leave it empty.
leave it empty. Yeah, make sure you didn't draw too dark accidentally. Interval notation. Interval notation wouldn't be appropriate. Interval notation is when you're only listing infinite number of values. So instead of interval notation, just maybe that 0 slash empty set, null set, that would be appropriate. Okay. Set builder notation. Also sometimes called formal set notation. So let me mark it here. Set builder notation. It looks pretty fancy. I'm not gonna lie. Maybe intimidating, but it's really not bad. It starts with, let me write this nicer. Do you know what that's called?
Incorrect.
Jack, what is it?
I didn't say I knew.
You knew it, it's not. Okay, yeah. Brackets are the square, parentheses are the, it's not a parentheses, not parenthesis. This is a brace.
Oh, yeah, I knew that.
Some people call it curly braces. I think that's a little redundant. It's just brace. So we start with that, and then it has an X. Then it has this line, which is kind of like half of an absolute value line. This is read such that. And then you just write this in there. So then it's and then you close the braces. Done. I don't think it's very practical for this class, but it's something to at least get used to. So like for this one, if I'm looking down here, if I want to do set builder notation for that, I'm going to start with a brace. Then I have X such that X is greater than or equal to -2. And that's it. That is set builder notation. Also sometimes called formal set notation. And the nice thing about this is that it opens it up for other variables because we could talk about X's and Y's, and it gives us a way to talk about them separately and clearly. So I hope that helps for your assignment. Now I'm officially done with today's lesson.
Doing inequality and stuff.
An inequality doesn't include the braces or the X such that. But you're right, it's just that
What is this like? It's like X is in.
yeah, it's just telling you what X is. It's X such that X is greater than 2. Yeah, it's weird.
It's not gonna be on the test.
It could be. Yeah, anything from the homework, anything from class could be on the test. Yes, Joseph. Let's see. Maybe the question is, what did I do wrong?